In this presentation, I will teach you product of sum form, which is an abbreviation for POS form. You have already studied the SOP form, so it will be easy for you to understand. I have taken the same truth table in which we have three variables A, B, C. So the total number of combination will be 2 to the power 3, which gives us 8. I have already written all the 8 combinations and output corresponding to them. Y is the Boolean function that we want to represent as POS form. We have already represented this Y as SOP form. Now we want to represent it in POS form. This we have done, and this we want to do in this presentation. So let's start with it. POS form is used when the output is 0 or low. So let me write this point down. POS form is used when the output is a low or a 0, whereas in case of SOP form we used it when the output is high. So let's see from this truth table for what cases the output is low. For the first two cases the output is low, and for this case the output is low. So there are three cases for which your output is low, so we have to consider these three cases only while writing the POS form. And if the variable is A and it is 0, if the variable is A and it is 0, then we will write it as A, and if it is 1, then we will write it as A complement. This is just opposite to what we have studied in the SOP form. In SOP form we studied if the variable is A and it is 0, we write it as A complement, and if it is 1, we write it as A. This one is for SOP and this one is for POS. So you have to remember this thing. It will be very helpful to you when you write your exam. So let's move to the POS form. Let's write it. The function is Y, and for the first case you can see A is 0, B is 0 and C is 0. So we will write it as A or B or C. And for the second case you can see A is 0, B is 0, C is 1. So A or B or C complement, we have to write it as C complement because it is 1. From here you can see. And for the last case we have A as 0, B as 1, C as 1. Now this we call as this 3 we will call as the max term, and in case of SOP form we had the min term, and we just call them max term or min term because of their size. If you write A or B or C, and if you write A and B and C, you can see their size. This is looking maximum because of its size, and this is looking minimum because of its size. That's why we call it as max term, and this one we call as the min term. There is no special reason for this. The functionality of the function Y will never change. If you want to represent it in POS form or in SOP form, it will yield the certain output depending upon the input. And this POS form written here I have obtained from the SOP form itself. So let's try to prove it that we can have the POS form from the SOP form, and I will consider the output when it is low. So Y is now Y complement, because you can see in SOP form when 0 we write complement, and here function Y is 0, so I will write Y complement. It is 0 for three cases. Let's try to find out the first case in which A is 0, B is 0 and C is 0. So I will write A complement and B complement and C complement, or in this case I have A as 0, B as 0, C as 1. So A complement and B complement and C. And for the final case when the output is 0, we have A as 0, B as 1, C as 1. So A complement, B, C. Now I want the left hand side as the output Y, not Y complement. I want it as Y. So what I can do, I can take the complement of both the sides, the right hand side and the left hand side. So taking the complement of both sides, let's see what we have. Y complement, and then again its complement, we have A complement, B complement, C complement, or a complement b complement c or a complement b c, and I will take the complement of the whole right hand side. We will use the De Morgan's law. I hope you remember it. And when you take the complement of something already complemented, like if you want to take the complement of a complement, you will have a itself. In the same way, the left hand side will have y. That's what we want, and we will use De Morgan's theorem now. If you have a or b and you want to take its complement, you will have a complement, the complement of the variable. This or will now change to and the b will now be written as b complement. We will use this law here, and we have a complement, b complement, c complement, and the complement of whole. This or will change to and we have a complement, b complement, c, then its complement. This or will change to and a complement, b, c, and its complement. Again, we have to use the De Morgan's law for these three min terms, and we have a, this and will change to or, b, this and will change to or, c. Okay, and in the same way we have a or b or c complement and a or b complement or c complement. This is the y. Now you may see that these two are same, and instead of going to the De Morgan's law every time, if someone asks you to write the POS form, it is not required to use the De Morgan's theorem every time to convert the SOP form to the POS form, but we can directly write down the POS form by this convention. You can use this convention. You use a when it is 0, you use a complement when it is 1. You just complement it. What we are doing here, De Morgan's law does what? It takes the complement. We are taking the complement of y complement. Instead of doing this, we just take the complement initially. You just take the complement of this thing and you have this convention. Use this convention and directly write the POS form like this. Now this POS form written here is the canonical POS form. Canonical POS form. We also call it standard POS form, and we write it directly from the truth table like we have already did. And in canonical or standard POS form, each max term will have all the variables in normal or complemented form. Here we have 3 max terms, and in each of this max term we have all the variables in normal or complemented form. In the first max term you can see we have a, b, c. There are 3 variables a, b, c, and in this we have a, b, c in normal form. In this we have a, b in normal form, c in complemented form, and in the last max term we have a in normal form, b and c in complemented form. So this is our canonical POS form. You can use the Boolean algebra to reduce this canonical POS form to the minimal POS form. I'm going to do it quickly, and in the next presentation we will solve few more examples on the POS form. So the function y is equal to a or b or c and a or b or c complement and a or b complement or c complement, and we want to reduce it by using the Boolean algebra. This is a good practice for you because you have already studied the Boolean algebra. In the first 2 terms you can see we have a or b as common, and from distributive law, if you remember, if we have a or b and a or c, we write it as a or b, c. So let's consider a or b as x. So we have x or c. From here you can see, and we have x or c complement, so it can be written as x or c and, let me slide this board, c complement. So y is equal to x or c and c complement, and from the last max term we have a or b complement or c complement. Now c and c complement is definitely equal to 0, and x or with 0 is equal to x, and x is equal to a or b. So we have a or b, and here we have a or b complement or c complement. Again you can see a is common, so from distributive law we have a or b, and I have to AND b with b complement or c complement. So let's try to find out the function y by the distributive law again. A or, I have to open this bracket, we have b and b complement, or B and C complement. B and B complement is definitely equal to 0. So we have A or B and C complement. And again, using the distributive law, we have A or B and A or C complement. So this is the minimal POS form, because in this you can see the first max term, this is max term, and in the first max term C is not there, whereas in the last max term or the second max term, we have only two max terms here, B is not there. So all the variables are not present, whether in normal or complemented form, thus we call it as the minimal POS form. It is very easy, and in exam they will give you the minimal POS form and ask you to have your canonical POS form. There are two ways to do it. The first way is to use the truth table. You can find the values of your output depending upon this expression and write the POS form like this that I have explained you initially, or you can have another method that I will explain you separately in one presentation. So this is all for this presentation. See you in the next one.